Section 2.4, Example 3 on page 119, we have in problem 2, the truck could contain any amount of concrete from 0 to 200 feet, such as 27.3 cubic feet or 105 2/3 cubic feet. You can connect the data points from the table because any point between the data has meaning. Some graphs may be composed of isolated points. For example, in the Solvate, you graphed only points that represent printing whole numbers of photos. So we have continuous graphs and discrete graphs. A continuous graph is a graph that is unbroken. So this graph right here represents every point on the line. A discrete graph is composed of distinct isolated points. So only where the points are on the graph are what we can use as solutions. The space in between does not work. Example 3 says, a local cheesemaker is making cheddar cheese to sell at a farmer's market. The amount of milk used to make the cheese and the price at which he sells the cheese are shown. Write a function for each situation. Graph each function. Is the graph continuous or discrete? We have 1 gallon of milk makes 16 ounces of cheddar cheese, and each wheel of cheddar cheese costs $9. If we let M be the number of gallons of milk, W be the weight of the cheese, N be the number of wheels sold, and A be the amount of money made, we can use these variables to make two equations. Since we get 16 ounces of cheese for every 1 gallon of milk, we can say 16 times the number of gallons will give us the weight. Similarly, since each wheel costs $9, the amount of money made will be 9 times the number of wheels we sell. Next, we can make a table to figure out a few values to put on our graphs. Since our equation is just multiplying by a constant, we can go ahead and just plug in some values like 0, 1, 2, 3, and 4 to get 16 times 0 is 0, 16 times 1 is 16, times 2 is 32, times 3 is 48, and times 4 is 64. Similarly, 9 times 0 is 0, 9 times 1 is 9, times 2 is 18, times 3 is 27, and times 4 is 36. Notice we're talking about gallons of milk and number of wheels sold. These are going to be positive numbers because we can't use negative gallons of milk and we can't sell negative wheels of cheese. So looking at the first few positive numbers will give us a good idea of what our graph will look like. If we consider the amount of milk we use and the weight of the cheese, we have 0 through 4 on our table for gallons of milk, and our weight goes all the way up to 64. So for the gallons, we can count by ones, but for the weight, we should count by something else. So I went ahead and counted by eights. Now, if we're talking about how much milk we can use, we can technically pour as little or as much as we want. So we don't have to use exactly 1 gallon or exactly 2 gallons. We could use 1.5 gallons. We could use 1.7 gallons. So we could use anything from 0 and up for the number of gallons. What this means is we can go ahead and draw a line through all these points, continuing on upwards forever, because as long as we have enough milk, we can keep pouring. That means that our graph of the milk versus weight is continuous. Now looking at the number of wheels sold, we can sell 0, 1, 2, 3, 4, just like the amount of milk we use. They're all going to be positive numbers. However, if you're selling cheese wheels at a farmer's market, you're probably not going to cut the cheese wheel into a bunch of little pieces and sell people 0.67 cheese wheels. Instead, you're going to sell an entire cheese wheel. So you could sell 1, 2, 3, 4, and so on, as many wheels as you had. So this too could go on forever. However, it's only going to occur on whole numbers of cheese wheels. So we won't draw a line through the second graph, and we'll say that this graph is indeed discrete. So anytime you can plug in any number at all, we'll call it continuous. When you have to use only specific values, that is considered discrete. The next few slides have information for each of these steps. Here's the information for the first graph with the line, and here's the information for the second graph with our final explanation. On page 121, we have number 5. The cost C in dollars for delivered pizza depends on the number of pizzas ordered P. This situation is represented by the function rule C equals 5 plus 9P.